So like there were no classes. That's when now they're taking classes.
Yeah. Now here we speak out refraction of a lens, refraction by a lens. The first diagram what we did last class is like, suppose this is a lens. Now this is what this is A, B and C. This is the curvature, and ADC is the second curvature. Now O is the object. Okay, O is the object and I is the image. Okay, O is the object, I is the image. Now, so this is the object distance. U is the object distance, and V is the image distance.
So the marker is a bit light.
Very light. Okay. Wait 1 second. Oh, wait. See, in the first diagram, this is the convex lens object. This is U is the object distance, V is the image distance, O is the object, I is the image. So we have taken this is the incident ray and this is the refracted ray. Now U is object distance, V is image distance, and the curvature is ABC is one surface and ADC is the second surface. ADC is the second surface. Now in the second diagram, what we have done is the first part is here, the second part is completely glass. Now what happened? We are taking the incident ray as given in the first diagram, and we have taken the normal for the surface. It is beating somewhere at C1, and the image is formed somewhere at I1. Okay, so I1 is the angle of incidence, R1 is the angle of refraction, and this R1 is what? R1 is the radius of curvature. Clear? Now the third one, what he says here in the third one. So okay, so now what happens is here the second one. Yeah, this is the image. Okay, so A, D, and C. This is the second part. Okay, are you able to see? See, you are not able to see. Move it little back. Now is it okay?
Yes.
Sorry, right? The entire is correct. Yeah. Now, okay. Now here ADC. So what happens? This is the radius of curvature. Okay, D. This is C2, and this is R2. This is N2. This is N1. Now, the image here it is what? I1. I is the final image. Okay. So what we are doing? This is meeting somewhere. This the object for the image for the first body. The previous diagram is acting like an object for the second one. Understood? This is the image of the first diagram. Is acting like an object for the second diagram. Understood? And the final image is formed at I. Is that clear? And the final image is formed at I. And this is what? This is glass. And this is air. Is that clear?
Yes, sir.
Now this is R2. R2 is the radius. Is that clear? R2 is the radius. And N2 is the glass and N1 is the air now. Now we will start from the lens diagram. Okay. I will start from the lens diagram. Just 1 second. Yeah, refraction at a spherical surface. What is the formula? Refraction at a spherical surface. What is that? N1 by what is the formula? N1 by minus U plus N2 by V is equal to N2 minus N1 by R. Clear? This is the formula. Now we are going to apply this on the second diagram. On this, then we'll apply on this also. Is that clear? N2 by minus U plus N1 by minus U plus N2 by V equal to N2 minus N1 by R. This derivation we did in the previous class. Is it not? Yes? Do you remember this one?
Yes, sir.
Okay, are you clear with these three diagrams, these three figures?
Yes, sir.
Yes, sir.
Oh. Okay. Okay, so Now we have n2 n1 by minus u is plus n2 by b is equal to n2 minus n1 by r. Okay. So now we are starting with the second diagram. Clear? The second diagram, if you see, that is ABC is the surface. Clear? For this ABC, the second surface will be ADC. Okay. In ABC, what we are going to take now, N1 by OB. This is the object, right? This is the object distance, U, and this is the image distance, that is V, and N2 minus N1 by R. So we are taking here N1 by OB, N1 by OB plus, because it is minus U, right? Because we are taking from here to here. So it is negative of negative will become positive. Is that clear? Negative of negative will become positive. I'll take here U is equal to, I'll take minus OB. Is that clear? And V is equal to what? Here V is equal to BI1, and R is equal to what? R is equal to the radius, right? Radius is equal to also positive now, BC1. R is equal to R1, which is equal to BC1. Okay. Now we will substitute here in the formula N2 by V. What is V? BI1 equal to what? N2 minus N1 by R. N2 minus N1 by R. R is equal to BC1. Is it clear with you all? First, this equation.
Yes, sir.
Okay, going with the next equation. This is, let it be equation number 1. Now going with the second, that is third figure. This figure. In this figure, we have ADC. Okay, ADC. In this ADC, what is object distance now? We have to find out the object distance, and we have to speak about the image distance also. Okay, object distance and image distance. So let it be like this is the normal. Okay, so this is what is this? This is ADC, and this is R, angle of refraction. Okay, and this one is angle of incidence, angle of refraction and angle of incidence. Now D, there is DI and DI1. So here object is what? DI1 is the object. Okay. So here in this case, U is equal to DI1. Is it positive or negative? It should be positive, right? Is it not? DI1, because it is in the direction of light. These two are in the direction of the light. So, and V is equal to what? DI, and radius R is equal to what? Again R2. What R2? Minus, it is DC2. Okay. The value is DC2. Okay. I'll write here R is equal to DC2. Now what is the answer now? N1 by minus DI1 plus N2 by DI equal to what? N2 minus N1 by DC2. That is N2 minus N1 by DC2. Is that clear? N2 minus N1 by DC2. So therefore, now what we are going to do for thin lenses, BI1 and DI1 will be same. For thin lenses, we are speaking about thin lenses. For thin lenses, DI1 and DI1 and BI1 both are same. DI1, BI1, they both are equal. Now, what we are going to do, we are going to add both the equations, equation 1 and equation 2. Is that clear? We are going to add both the equations. So 1 plus 2. So add LHS to LHS and RHS to RHS. Add LHS to LHS and RHS to RHS. So what will happen now? N1 by OB plus N2 by BI1 minus N2 by N1 by DI1, okay, plus N2 by DI, which is equal to N2 minus N1 by BC1 plus N2 minus N1 divided by DC2. Is that clear? N2 minus
Yes.
N1 by DC2. See, once again from the beginning. Yeah. Yeah, I'll explain all the diagram figures from the beginning. See once again. You have the here, this is refraction by a lens. Okay. And or we can also say this is a lens. Yeah, this is also known as lens maker's formula. Okay, what we are going to do is lens maker formula. Now this is a convex. This is a convex lens. O is the object, I is the image, U is the object distance, V is the image distance. So this is the incident ray, this is the refracted ray. Is that clear? Now what happened? Now in the second diagram, this is completely air and this one is completely glass. This part is air, this part is glass. Like what we studied in the previous derivation, refraction at a spherical surface. Now this is the object and this is the normal and this is the refracted ray. Image is formed here at I1. R1 is the radius of curvature. Next is glass, from glass to air. So what happened? This is the second surface, curved surface area we have taken. Now the object for the first, this figure is acting like a image for the image for this one is acting like an object for the second one. Image, this is the image of the first diagram. This is acting like an object for the second one, and the final image is found here. The final image is found here. This is a virtual image. Okay, sorry, this is a real image of the first diagram. Understood now? Is that clear?
Yes, sir.
Yes, sir.
Yes, madam.
Yes, sir.
Okay. Now we are taking, this is the formula which we got it from refraction at a spherical surface. This is a formula, n1 by minus u plus n2 by v is equal to n2 minus n1 by r. Now we are taking the first surface, this one, ABC curved surface area, refraction at a surface. So u equal to minus, this is object distance, and this is the image distance.